The synergy between hyper-realistic avatars and large language models. Artificial intelligence has made significant strides in both visual representation and natural language processing. Hyper-realistic avatars represent a leap in visual AI, creating virtual entities that closely mimic human appearance and movements. Simultaneously, large language models have revolutionized text-based AI interactions by enabling machines to understand context and generate coherent responses. This paper examines the convergence of these two domains, highlighting the significance of merging visual realism with advanced conversational abilities. The objective is to explore how this synergy enhances user experiences and to discuss its implications across various industries. Hyper-realistic avatars are digital representations designed to closely resemble human beings in appearance and behavior. They play a crucial role in human-computer interaction by providing a more engaging and relatable interface. These avatars aim to bridge the gap between virtual entities and humans, enhancing user comfort and interaction effectiveness. Advancements in 3D modeling and rendering techniques have allowed for the creation of detailed and lifelike virtual humans. Motion capture technology records human movements, which are then applied to avatars to produce natural gestures and expressions. Additionally, deep learning algorithms contribute to visual realism by improving texture mapping and animation, enabling avatars to exhibit subtle facial movements and emotions. The uncanny valley refers to the discomfort people feel when interacting with entities that are almost, but not quite, human-like. Psychological factors such as perception and familiarity influence this phenomenon. Design principles that focus on enhancing realism while maintaining a balance between human and artificial elements help overcome this barrier. By refining visual details and movements, developers can create avatars that users perceive as more natural and less unsettling. Deep Brain AI has developed avatars that exemplify the pinnacle of virtual human engineering. Their avatars are not only visually impressive but also exhibit movements and behaviors indistinguishable from real humans. These avatars find applications in various industries, serving as customer service representatives, brand ambassadors, and even news broadcasters. By providing a touch of realism and relatability, they enhance user engagement and satisfaction. Large language models represent a significant evolution from traditional natural language processing techniques. Models like the GPT series have the capacity to process vast amounts of textual data, enabling them to understand context, semantics, and the relationships between concepts. LLMs excel in contextual understanding, allowing them to generate responses that are relevant to the input they receive. They can produce coherent and fluent text, making interactions with users more natural. Their conversational abilities enable them to handle complex queries, provide detailed explanations, and engage in multi-turn dialogues. Despite their capabilities, LLMs face challenges such as inherent biases present in training data, which can lead to unethical or inappropriate responses. Additionally, they require substantial computational resources for training and operation, which can be a barrier to widespread adoption. Integrating hyper-realistic avatars with LLMs involves synchronizing visual and language data to provide seamless real-time interactions. Addressing latency issues is crucial to ensure that the avatar's responses and movements align with the conversational flow, enhancing the overall user experience. The combination of visual realism and advanced conversational capabilities leads to more natural and engaging interactions. Users can communicate with avatars that not only look human but also understand and respond appropriately, creating emotional resonance and empathy in conversations. In-Worlds platform allows users to customize avatars with specific backgrounds, personalities, and dialogue styles. This level of personalization empowers creators to design unique AI-powered characters tailored to specific audiences and scenarios. By leveraging LLMs, these avatars can engage users in meaningful interactions, enhancing engagement and efficacy. Hyper-realistic avatars powered by LLMs serve as virtual assistants, providing personalized support and handling customer inquiries efficiently. They can operate around the clock, offering consistent service without human limitations. In the educational sector, avatars function as interactive tutors and companions, delivering personalized learning experiences. They can adapt to individual learning styles and provide explanations that enhance understanding. In gaming, non-player characters, NPCs, enhanced with LLMs offer advanced interactivity and realism. Players can engage with NPCs in more meaningful ways, leading to immersive gaming experiences. Virtual therapists and patient engagement tools utilize avatars to provide support in healthcare settings. They can assist in mental health applications, offering anonymity and comfort to patients. Avatars act as virtual brand ambassadors, creating interactive campaigns that engage consumers. They can deliver personalized marketing messages and gather feedback in real time. The use of avatars and LLMs raises concerns about privacy and data protection. Ensuring that user data is handled responsibly is essential to maintain trust. The technology could be misused to create deepfakes or deceptive content, leading to misinformation or harm. Addressing this potential requires ethical guidelines and technological safeguards. Extended interactions with hyper-realistic avatars may have psychological effects on users, such as blurred lines between reality and virtual experiences. Understanding and mitigating these impacts is important. Designing avatars and LLMs that are accessible to all users, including those with disabilities, ensures inclusivity. This involves considering diverse needs in the development process. The deployment of these technologies must comply with legal frameworks that address intellectual property, consent, and liability issues. Ongoing research aims to improve AI algorithms, enhancing the capabilities of both avatars and LLMs. This includes developing models that require less data and computational power. Combining avatars and LLMs with augmented reality (AR), virtual reality (VR), and the Internet of Things (IoT), can create more immersive and interactive experiences. Future developments may focus on increasing the personalization of avatars, enabling them to adapt to individual user preferences and contexts more effectively. The widespread adoption of these technologies could influence employment, particularly in roles involving customer interaction. Preparing for these changes involves considering retraining and job evolution. The integration of hyper-realistic avatars with large language models represents a significant advancement in artificial intelligence. By combining visual realism with advanced conversational abilities, these technologies enhance user experiences across various industries. While the potential benefits are substantial, it is essential to address ethical considerations and societal impacts. Collaboration among technologists, policymakers, and stakeholders is crucial to harness the transformative potential of this synergy responsibly.